Okay, so in this video we're going to talk about another type of 2D motion, or another type of two-dimensional motion, and that is circular motion. Circular motion is motion that occurs in a circle, right? So here you have a motion diagram that represents that. These green vectors, these are the velocity vectors, and these vectors here, these are the acceleration vectors. You can see that the acceleration vectors, they all have the same magnitude, and they all point towards this point here, right? So they all point that way, all of them. So that's a characteristic of circular motion. How do we get this acceleration vector? So for instance, you take this vector here, and then you take this other vector here, and you do this minus this, which is this plus minus this one here, and you get delta v, which is a vector that goes in this direction. Divide that delta v by delta t, and then you get your acceleration vector right there. So circular motion is a motion that is basically characterized for an acceleration vector that points towards the center of the circle, right there. So it goes in a circle, as the name implies, and this acceleration that points towards the center of the circle, we call that centripetal acceleration. That is just a name for this particular type of acceleration. It doesn't mean that it's a new physical quantity. It's just an acceleration that has a particular name, centripetal acceleration. So circular motion happens in many instances. For instance, if you look at a car going through a bend like that, this portion of this portion here, that can be thought of as circular motion, right? A portion of a circular motion. And then you would have a displacement vector for that portion, and then you would have two velocity vectors that then you can use to calculate the change in velocity, right, which is v2 minus v1, and from there you can get the acceleration. So now if you look at this, right, so let's just go back to this. So we have that portion of the circular motion, right? So this is the center of the circle, right? A circle is defined by a radius. So this is the radius of the circle, and this is an angle theta, right? That describes how much this triangle is open here, right? So the displacement is this blue vector here in going from 1 to 2, right? And then in this portion of the circle, right, so you have two velocity vectors. So now let's calculate the acceleration. So to calculate the acceleration, we take v2 minus v1, and we get this delta v vector here, right? And now we can see that this triangle here is similar to this triangle here, right? So we can say that d over r, right? D over r is equal to delta v over v1 or v2, right? Which is the same here, right, in magnitudes. So, and now we get this equation here. So we can write then, we can use this to write that delta v over v is equal to v delta t over r. Where is that v delta t over r comes? That's the displacement, right? The displacement is v times delta t, right? So you get v delta t here, and now you can send this guy multiplying here, and you get delta t over the delta v over delta t is equal to v squared over r, and this is your acceleration. So here we get an equation for the centripetal acceleration, v squared over r. R is the radius, v is the velocity, and it always points towards the center of the circle. So let me just go back to this picture here. So to summarize, the circular motion is a motion that is in a circle. It is defined by the radius r. The acceleration has a magnitude, v squared over r, and it always points towards the center of the circle. The magnitude of these velocity vectors is always the same. You can see it, they have the same length. What changes is the direction of those velocity vectors. So let's use these ideas to work some problems here. So we have world-class female short track speed skaters, and they have a 500-meter race in 45 seconds, right? So during the race, there are some turns, and we want to calculate the centripetal acceleration in a turn, right? So the radius of the turn is 11 meters. So what we are going to think is that when the skaters are going through that turn, right, in this portion here, that's a circular motion. So then remember that, so this is a circular motion, so the ring, let's say something like this. So this portion of the turn here, that's a circular motion, right? So the skaters are going to go through that motion there. So then we can now calculate the velocity, right? So it's a 500-meter race in 45 seconds, right? So 500 meters divided by 45 seconds, that gives you 11 meters per second. So now I have my velocity, right? So that's velocity, and that is supposed to be an equal here. And now I can solve to find the centripetal acceleration. What is that? It's v squared over r. The radius is given to you, the speed we just found it, and that gives you 11 meters per second squared. To compare that, the acceleration of gravity is 9.8 meters per second squared. So this is close to the acceleration of gravity. So let's look at another problem, turning a corner in a typical large intersection in a city. So while driving, to do that, you have to drive your car through a circular arc, and the radius is about 25 meters. So they tell you the maximum advisable acceleration of your vehicle through the turn when the pavement is wet should be 0.4 times g, the free acceleration. So you get 0.4 times g. So what is the maximum speed that you can have? Well, this is the maximum acceleration, right? So this is your acceleration. And then you know that this is equal to v squared over r, right? So v squared is what you want, and r is given to you here. That's 25 meters. So then you can actually get that. So you can write a is equal to, well, let me just write it like this. So a, which is 0.4 g, is equal to 25 meters, and that, sorry, not 25 meters, that is v squared divided by r, which is 25 meters. So that implies that v is equal to the square root of what? I'm going to get the square root because I have a square here, right? Is equal to 0.25 meters times 0.4 g. And so, and that is equal to, I can use my calculator quickly here. So I have, let's see, I have, be clear here, I have the square root of what? Then is 25 meters. There's not this 0.5, right? So this is 25 meters times 0.4 times g, which is 9.8. That gives me a square root of 98, and this is roughly 10, right? Because 98 is close to 100. So this is roughly 10 meters per second That is the maximum speed that it is safe for you to drive through that turn.